So I'm going to go through the some of the reactions. You have to balance them, starting with number 1. When you've got the magnesium reacting with water, I suggest you write it as HOH because it will help you identify what the products are. You may not have noticed it, but there are tiny little bubbles on the magnesium ribbon. So when you do your reaction, write it like this. It'll help you predict the products much better. Same thing when you do number 3 and you're reacting with calcium. In number 4, they ask you to compare the reactivity of the group 1A metals, which are the alkali metals, with the group 2A metals, the alkali earth. Now remember, I demoed potassium and sodium in water, and I also showed you the video of what happens when you put potassium, sodium, cesium, and francium in water. So you can look at those videos, or just remember what happened when I put the alkali or group 1A metals in water compared to these. For number 5, we're reacting magnesium with oxygen, and you can look at Appendix E to remember what happens when you combust a metallic oxide. For the second part of the equation, we took the ashes, the magnesium oxide, and we mixed it with water. Once again, usually it's better to write water as HOH. What you have is a synthesis reaction. You're going to end up with one product, magnesium hydroxide. And then once again, you need to go and balance that reaction out. For number 6, we are reacting aluminum foil and water. In this instance, there was no reaction. And so then we took some aluminum foil and we reacted it with HCl. That indeed did react. Number 7, we took aluminum chloride and we reacted it with sodium hydroxide. What we have here is a double displacement reaction. You switch your 2 cations or you switch your 2 anions. Now remember, it's been a while, but you switch the symbols, not the subscripts. So you have to go back and rebalance each of these. So that means we're going to need 3 there. That's already balanced. And then of course you balance the whole reaction. Normally aluminum hydroxide will have 3 hydroxides. That was the white solid that formed. But as you kept adding sodium hydroxide, kept adding this, you added more and more hydroxide. If you have very large concentrations of hydroxide, you can get something interesting to happen. The aluminum will take on more hydroxides than it should. And form what's called a aqueous ion. And this will dissolve back into solution. So that's why when you first started adding it, it turned white, And as you kept adding more sodium hydroxide, it dissolved away again. Of course, go and balance these reactions. For number 8, we had zinc plus water, copper plus water, and iron plus water. For all of these reactions, well, not all of them, the first two are no reaction. Copper is what we make our pipes out of, our plumbing. Obviously, we wouldn't want to have our copper pipes rusting away. Same thing with zinc. We use those for nails and construction. We wouldn't want our nails rusting away. Iron does rust. If you look very closely, you would have seen tiny little bubbles. And the bubbles forming would have been hydrogen bubbles. It doesn't matter if you pick it to be iron 2 or iron 3. You should be able to balance the reaction either way. For number 9, we then put these 3 samples with HCl. The only one that didn't react was the copper. For the iron chloride, you can pick iron 2 or iron 3 to balance it. And again, it is up to you. That covers all the different reactions. So with that, I will end it.